This video demonstrates the ease of using IGW to perform a mass balance analysis in an interactive and real-time manner. The video illustrates how to add sources and sinks to a model in a step-by-step manner. The impact of each additional source and sink is displayed immediately in the mass balance visualization. The source and sinks added are prescribed head boundaries, such as rivers or creeks, two-way head-dependent flux boundaries, such as lakes and ponds, one-way head-dependent flux boundaries, such as drains, recharge to the aquifer, and pumping from the aquifer. A transient model in which pumping rates change with time are also simulated to illustrate the impact on the mass balance and the resulting changes to the seepage area predicted by the model. The steps to create the model are as follows. 1. Create a domain polygon covering the workspace extent and edit the polygon in Attributes Explorer. In the Flow Properties tab, check the Conductivity box and assign a constant value. In the Elevations tab, check the Top Elevation box, assign a constant top elevation, and uncheck Use as Starting Head. Next, check the Bottom Elevation box and assign a constant thickness. Two, create a polyline along the left edge of the model. Assign this as two-way underneath the head-dependent flux, and open the Polyline Attributes table. Assign a river stage of 5 meters for each section of the polyline. Three, create a polyline along the right edge of the model, and assign as two-way underneath head-dependent flux. Use the creek designation from the pull-down menu, and open the Polyline Attributes table. Use the default values for the river stage. 4. Select the Domain polygon in Attributes Explorer and check the Zone Budget box at the bottom of the window. 5. Discretize the model and reopen Attributes Explorer. In the bottom left window, check Water Balance under Zone 2. Note the water balance chart that opens. 6. Run the model. Note the mass balance terms that appear in the chart after the model has been solved. The river is the source to the model, while the creek is the sink. 7. Click the Reset Toolbar icon, then open Attributes Explorer. In the Source and Sinks tab, go to the Prescribed Flux subtab, check Recharge, and assign a constant recharge. 8. Discretize and run the model. Note the new source term representing recharge in the mass balance chart. 9. Add a lake polygon near the left edge of the model domain. In the Source and Sinks tab, go to the Head-Dependent Flux subtab and check Two-Way Head-Dependent Flux. Assign a constant stage and a constant bottom elevation. 10. A shallow discretization is needed to incorporate the lake. Run the model and note the new flow patterns in and around the lake. Also note the lake as both a source and sink term in the aquifer water balance. 11. Add a pond polygon near the left edge of the model domain. In the Source and Sinks tab, go to the Head-Dependent Flux subtab, check Two-Way Head-Dependent Flux, and change the designation to Pond from the pull-down menu. Assign a constant stage. 12. Discretize and run the model. Note the pond as both a source and sink term in the aquifer water balance. 13. Add a pumping well just to the left of the pond and perform a shallow discretization. Then run the model. The well is represented in the updated mass balance chart as a model sink. 14. Add a drain polygon near the right edge of the model domain. In the Source and Sinks tab, go to the Head-Dependent Flux subtab, check One-Way Head-Dependent Flux, and use the default settings. 15. Discretize and run the model. The drain polygon is represented in the mass balance as a sink term. In the display options, check the Seep Area box to show the grid cells in which seepage out from the aquifer to the surface occurs. 16. Add a well just to the left of the drain polygon. In Attributes Explorer, select Pumping as the well type. Then select Transient and open the Transient option window. Uncheck Random Fluctuations and Periodic Fluctuations, then click Edit. Change the recycle period and click OK. Click Redraw, click OK, and close Attributes Explorer. 17. Click on the clock icon and select a transient state model and use the default settings. 18. Discretize and run the model. Note the changes to the water balance chart in the predicted seepage area as the model proceeds from one time step to the next. There is also a store term added to the water balance, which represents the water released or taken from aquifer storage.